All right, I think that's 2 minutes after. We'll go ahead and get started. Um, Hello, everyone. Thank you for joining us today. My name is Michaela McShane, and it is my privilege to welcome you to the Startup NASA Feature Series, hosted by NASA's Technology Transfer Expansion Program, T2X, which expands the tech transfer mission of ensuring that innovations developed for exploration and discovery are broadly available to the public, to include a focus on entrepreneurial innovation and strategic partnerships to accelerate commercialization. This monthly series is an opportunity for NASA technology-inspired startups and innovative organizations to share their experience. This month, we'll hear from New York Tech's Entrepreneurship and Technology Innovation Center, or ETIC. Established in 2015, the ETIC is the NYIT College of Engineering and Computer Science Business Accelerator that brings together industry, government, and academia to demonstrate, test, incubate, and advance new ideas and technology in a resource-rich university environment. Before we jump into speaker intros, I'd like to point out that your microphones will be muted throughout the presentation. So if you have questions, please type them in the chat box in the lower right-hand corner of your screen, and we will answer them at the end. It's my pleasure to introduce today's speaker, Michael Nizick, the director of the Entrepreneurship and Technology Innovation Center and an adjunct associate professor of computer science at New York Institute of Technology. He has more than 25 years of professional experience in information technology in a variety of industries, including aviation, education, law enforcement, biotechnology, and cybersecurity. Nizick has held IT leadership positions in both private and publicly held companies. With more than 10 years of college-level teaching experience, Nizick holds a PhD in Information Studies from Long Island University, a master's degree in Technology Systems Management from Stony Brook University, and a bachelor's degree in Computer Information Systems from Dowling College. Through ETIC programs, Nizick regularly connects both domestic and international students with internships and full-time positions in cybersecurity. He also directs New York Tech's Center of Academic Excellence in Cybersecurity Education, designated by the U.S. Department of Homeland Security and the National Security Agencies, and serves as a member of the CTEA Committee for Cybersecurity for Suffolk County Community College. And with that, I'll hand it over to Mike and the students to talk about the program.
Great. Thank you so much, Michaela. And thank you to Christy and Hia and everybody at T2X for allowing us to speak today. We hope you find it interesting. I have an amazing group of people you're going to meet in a little bit. And I hope that you learn from what we're going to tell you. And I hope that you can kind of get an idea of how this relationship that we're going to talk about today works and how it can benefit the not just the institutions, but NASA and also the country as a whole as we see it. So what I do want to start with is an introduction to a very special person, Dr. Babak Beheshti. Dr. Beheshti is the Dean of the College of Engineering and Computing Sciences, who leads literally every part of this part of the university that makes the particular contract and agreement that we're going to tell you about today possible. Without the programs at the College of Engineering and Computing Sciences and the faculty and the students, the program is not possible. So with that, I'll hand it over to Dr. Beheshti, and let's hear from you.
Thank you, Dr. Nizick. Hello, everyone. Good afternoon, everyone. Thank you to the T2X team for making us part of this presentation. I'm really happy to be a part of this. Just for the folks so that you know who we are, where we're at. New York Institute of Technology has 2 campuses in the New York area, one in New York City and one on Long Island, about 45 minutes outside of New York City. We have just about 7,000 or 8,000 students combined in our campuses. We also do have a graduate center in Vancouver, British Columbia in Canada, with our cybersecurity program and energy management program. Within the College of Engineering and Computing Sciences, which is the largest academic unit within the university, we have 8 undergraduate programs, 8 master's programs, and 2 PhD programs. ETIC, as you will be hearing more about it in today's presentation, is really our center of activity for, as you heard, government, industry, and academia interaction and interface. You'll be hearing from our awesome students in the that you see in the back, which have been really the main ingredient of this amazing recipe that we are in the third year of with NASA. Through this very unique contract, our students, under the leadership of Dr. Nizik, form interdisciplinary teams to develop prototypes for select NASA patents. The experience has been truly transformative in the past 3 years that I've witnessed this, both for the institution as well as for our students. It is a win-win for all. It's a definite step towards commercialization of many patents that NASA produces, and ultimately leading to many tech startups that now have a much more solid footing in pursuing a particular product as opposed to a fairly abstract patent. So with that said, I'll stop talking and pass it back to Dr. Nizik for the exciting discussion that you will hear.
Great.
Dr. Nizik.
Thank you so much, Dr. Breshti. So without further ado, I want to introduce a few special people to you. So we have, I'm going to say just Lincoln. I'm going to give the last names right now, but Winston, Pranav, Brandon, and Joanna. These are a few of the students. We also have a student who will be joining remotely, Mikhail. Those students are between the disciplines, as Dr. Breshti mentioned, the mechanical engineering, electrical engineering, computer science. Those students work together in these teams to kind of make this happen. So this is a sampling of a larger group that we have, 16 total students that are currently working at 2 different ETICs at 2 different campuses. So these are the students that these are the folks that make the reality, make it happen. And on top of that, we're going to kind of give you a presentation of how it all works. All right. So Mikhail, I'm going to share my screen. Okay. Okay. So to start with, we'll just give you a quick background of what ETIC is and the history, give you a quick background of the T2X program, the contract history. It is a contract, it's not a grant, so it's a very, from our understanding, it's pretty unique. I don't know how unique it is, but it's something that we haven't experienced before, but it's a very a great way to do it, and I'll explain that through the process. We have finished 2 full years of prototype design, including 9 prototypes that have been created, finished, and delivered. We're in our 3rd year of prototypes with 5 more that we're about 75%. Don't get mad at me, but we're about 75% done with them. We are getting ready over the summer to package those and deliver those. So it's a very successful track record so far. And then we're going to go over kind of summary and next steps on what it means to continue this, what we want to do next with it, how do we grow it, and then of course, bless you, and of course any Q&A questions you might have for us. So just a quick background, our ETIC, the Entrepreneurship and Technology Innovation Center, the first one here at Westbury that we're sitting in now, opened in 2015. The ETIC in New York City, our campus, opened 2022, and is already part of this this system that we work with, where we collaborate between the students between 2 different campuses. And we work on different grants and different types of contracts that we get in addition to this. But overall, we are recognized as a New York State business incubator. So we don't just build prototypes, we help companies formulate, are those prototypes viable? Are they things that can be scalable, right? We do that type of work as well, including business plans and financials and everything else. So we have a wide variety of services we offer. In this case, for NASA, we have a very unique skill set and benefit that they can, it's been a very collaborative agreement so far. So we have a number of different educational programs that are volunteer in nature. We have our interest program, which is remote sessions in technology. We have our Ursula robotics program, our student entrepreneurship program, and our intellectual property program. So we teach students and entrepreneurs in the area about everything from trademarks and patents and copyrights and intellectual property. We also teach them kind of how to become an entrepreneurial thinker. Which is very important to us. We also have a number of student startups over the years that have started up and moved on and graduated from our incubator. And our focus more recently has been on the NASA contract and how we can get more and more students involved. And have recently even moved into the 9 to 12 environment, which we'll talk about too, how we even reach into high schools now and are able to engage them at the same level. So this program, initially started with about 5 students, and now with our certificate program that we've started recently, where about well over 30 students in the last 2 years that have benefited from this program, not just from the experiential learning perspective, but also just from a career perspective, have gone into all kinds of Fortune 500, Fortune 1000 companies, and also into national research centers and labs as well. So we know it's successful. We just want to kind of tell you what we've seen and why it's successful. So this is our ETIC in 2015. I was hired in 2016, and now it's almost unrecognizable. But now when we take that same lab, that same prototyping center that we're able to kind of build anything in one spot, now we apply our geniuses at our multiple different programs. And when we do that, we wind up getting a lot of magic that happens that allows us to produce things at levels that are really commercial in nature. The level that you're going to see throughout some of our demos today is nearing a commercial level. So it's not just prototypes that can be demoed and function to investment groups from a company's perspective, or from the T2X office. They're able to kind of show these to prospective licensees. These prototypes are becoming more and more they're approaching more of a commercial application, where they're getting better and better and stronger each time we do it. And there's reasons for that too. So some of the things we've worked on already are the C gauge. That's NASA T2X office has TOPS documents that are their literature that they use, plus the patents themselves. So what you see is a combination of the two that we have here in this example. But we've already built and delivered the C gauge, a functional C gauge prototype, a functional C gauge trajectory impact solution, a functional exoskeleton vest, and one of the things I always like to talk about during these types of events is something called Heartbeat ID, which was an algorithm and a concept, but wasn't a software package yet. And we actually built a software package that demonstrates that algorithm real time for anybody who's interested in seeing if the algorithm actually works. So we have a high level of ability to prototype at certain levels, as long as it's in our wheelhouse and in our kind of niche, as they would say. But more so being able to deliver these in a way that are actually we can demonstrate them at different locations, right, or on different sites. That's really what we do also. Once again, just to put this into perspective, this is not just a kind of college program and let's get students' hands dirty and let's help them to understand what the real world is like. This is a contract. We have deliverables, we have deadlines, we have phases, we have meetings every 3 weeks. The students have to actually, you'll hear from them in a little bit, but students have to report to the NASA T2X office and report on the good and the bad. They report on the good progress, they report on what they can't solve, they report when they need help, and this is, we won't call it a pressure cooker because we don't really treat it that way, but sometimes it can be, and they'll tell you, sometimes it can be when we're not making the progress we need to, and we have to have a breakthrough. And the students get to experience that firsthand in this lab and in the center. And primarily, I like to stress on the fact that the reason that is because it's a contract and not a grant. And that's one of the key factors that we have requirements to meet to continue that contract. So last year, very recently, we did an event similar to this. We just haven't really updated this slide with the new pictures yet, but last year we met with T2X at our New York City campus, ETIC, and we're able to kind of demo and show them all the current progress of that year. And this year we were able to do it again at the annual meeting in the city. We were able to host it, which is wonderful and a treat for us to be able to host it for the team. But on the same note, our students were at the campus showing all of the different technologies that we were currently producing for this year. We're working on another 5 this year, as I mentioned before, that we're about 75% done with, and those are able to be kind of demoed. So what did we do? So far, we've delivered C gauge, we've delivered Heartbeat ID, we delivered trajectory impact, we delivered exoskeleton, we delivered nanofiltration, we delivered Puma, which we're going to see today. Yeah, over there. We delivered Puma. We delivered intelligent network design, which is one of our really only first and only currently AI-based products. So we are in that sector now. Low-speed motor controller. We've already finished, but we haven't delivered yet battery prognostics. So these are all patents that NASA has selected and given us the option to choose or not. These are ones that fit with things we were definitely able to do. We don't really take on anything that we can't do. It's not fair to either party. And currently underway, we have zone RainCat, variable visibility glasses, and wearable RFID, which are the current technologies we're working on in this year's contract, right? So to give you an idea of what this really means is we take these technologies and we take the TOPS document that NASA, the T2X office has created. We start with that and we get an idea of what this technology is supposed to do, what the claim is to as far as what it does and what it's used for, and the ideas that we learn about that the T2X office has figured out where these commercial technologies could be used, right? So we kind of have to learn about what they're doing first. And then we wind up taking the intellectual property concept, the patents, and we read the specific claims of the patents. And by the way, the students will tell you their experience with this, but the students wind up having to learn how to read a patent, how to learn how to read a diagram and apply it to the text-based portion of the patent and to figure out what the claims really are. And then we make a proposal to the T2X office to say, we can build it this way, and this is how we're going to meet these claims. And then we come to a collaborative agreement where that's going to be able to solve the problem of showing the technology to anybody who's interested in licensing it. And then that's what we build. To give you an idea of some of the levels of complexity that we work in so far, we've as part of our requirement to T2X office, we wanted to be able to give them a system that we won't be talking about today to kind of show the technology. It's a proprietary system, but on the same note, we built some videos for them that are, we engage with our creative students over in School of Design, and we have them create videos for our technology. So this is one of the videos that we'll show here. I'm going to jump a little bit through it because sometimes it's a little bit tedious before we get to the actual technology, but overall, these are the videos that NASA gets from us that allow them to show their tech. Say it's not currently in their hands, someone else is using it at NASA or whatever it might be. So we start with a description of the patent. We start allowing them to take a look at some things. Now, in this case, C-Gauge is a device that sticks on a rope or on a cable. And as the cable stretches, C-Gauge reports back to the actual base station that they have as part of the patent. Now, in this case, let me just jump here. So in this case, none of this really existed. We had to create everything from the CAD design of all the different specs. Everything that was spec'd out here, the actual sensor that's inside of the device, the Raspberry Pi computer and the Linux operating system, the Python software that reports to our web-based configuration. Every part of that had to be created from scratch. All we had to work on was the patent. So in reading the patent and figuring out what the device was, we had to come up with our own way to kind of demonstrate this as far as what it does. So in this case, that rope is being pulled, the C-Gauge is stretching, and that computer on the bottom is reporting it to the web-based component that we built with also. So everything from the ASP.NET solution, C# solution, everything is built in-house by us, right? Collaborative, student work, all working together. Each one has their specialty, and when it comes together, the electrical engineering students and the computer science student and the mechanical engineering student all work together as a team to build one device that none of them could build on their own, really. So that's a good example of one. And then one of my favorites is Heartbeat ID. So Heartbeat ID was, let me just move this out of the way for us. So Heartbeat ID was one of these algorithms that NASA had that compared people by their PQRST differentials in their heartbeat, and it compared them to a level that you could authenticate somebody to a system, to a door, to a camera system, whatever it might be, based on their heartbeat and nothing else. No passwords, no biometrics, nothing else, just the heartbeat itself. So this was an algorithm. Nothing else existed for this. So everything that you see going forward, the software itself didn't exist. We figured out the algorithm, we coded it, we created the products and the classes in Java, and NASA has a demonstration version of the software that actually takes a CSV file, a spreadsheet of real EKG data, bring it into the system and compare it to a known database of users in our system and pretty accurately determine whether they were the same person or not, using their algorithm. Okay. So basically, just as an example of the heartbeat, that's one technology that we built was not existing at all. It wasn't even in any kind of a real prototype version. That's how we understand it, and that's something that we like to show during these things, to show that level of development. So again, one of the things that makes this possible is really the students. So what I'm going to try to do right now, and I'm going to give them, a few minutes each to talk about kind of some things they've worked on, their experience when they first came in to when they are now. One thing I want to just kind of introduce to you is that this program, and again, my sincerest thanks to NASA, of course, but to T2XR specifically, because the constant support has allowed us to really think through things that maybe they didn't work at first, but we figured them out. And one of the things that we figured out was to have a certificate program that gave a student who came in to this program on a volunteer basis, really to get the ability to work on something, is one level. Then we have the ETIC intern position, ETIC engineer position, and ETIC product manager position. So each of these students that you see behind me is an ETIC product manager. And they've all graduated from the certificate program to the intern to the engineer. So they had to actually perform at certain levels, had to go through an interview process for the promotion. They had to learn how to get a promotion, what a promotion was. So on top of everything else we're doing, this program has provided our students that go through the program with this real world experience, which is really second to none, in my opinion, and seeing it firsthand. So without further ado, I'm going to introduce the students. I'm going to go from right to left. So I'm going to start with Joanna. Joanna is a junior now. Congratulations, right? You're now a junior as a computer science student. Well, next year, right?
Well,
all right, not for this.
I am so
Well, Joanna's a computer science student. Let's say that. So, Joanna, let's hear from you.
Joanna Sroka. I am a computer science student concentrated in data science. So I will be going to my science master's. However, starting here at ETIC, my first job, my first role or niche or specialty, as I could say, was about sensors. So I'm the sensor person. So I started off working with a lot of different sensors like IRs, gas, thermals, like weather sensors, motion, anything like that. And now during these patents, I can configure anything and understand how these sensors work. So if anyone has trouble with like heartbeat sensors, or right now we're working with EMG or EKG sensors, I'm the person who can understand the sensors and help work with that. So yeah, we all work as a team here as well. Even though I do some of the soldering, like PCB circuits, I've learned to be really good at it. I was really bad at first, but after a while, started to put the sensors into PCB circuits, so I learned how to do circuits. And then components, all the mechanical engineers here helped me to understand a lot of materials, and a lot of circuitry as well, and electrical engineers. Just like Lincoln here, he's working on zone pattern with me, and he's doing all the physical components while I'm doing the hardware and I'm doing software stuff. So yeah, we all really work as a team, and it's really great to be here.
It's one of the things that we see that's, and you don't always expect it. It's just sometimes there are things that I experience personally too that are very rewarding, and that's something that the almost exponential growth and knowledge acquisition of these students and working with each other. It's really amazing to see the mechanical engineering students work with the electrical engineering students, with the computer science students, and they're all kind of teaching each other and working. Yeah, anyway, thank you, Joanna. So, and Brandon's our senior, senior mechanical engineering student. So Brandon's been here for a few years now, and Brandon's a product manager. So go ahead, Brandon.
Hi guys, I'm Brandon Castellano. I'm a senior studying mechanical engineering. I've been here for almost 3 years, 3 years in October. It's been a great ride. I've worked on 5 NEST patents over the time. And I think ETIC has really changed my mindset, not just about what I'm doing in college, but after college, And I think it just even boosted my grades. So from taking what I'm learning in the classroom to bringing that into real life practical applications and actually building upon that, gaining my experience is really just phenomenal. And I couldn't have asked for a better program to do this. So with the program, I'm studying mechanical engineering, as I said, but it's not just about what you're doing in your major. This program allows you to not just take one specific field, but broaden your field, as John was saying. It's very interdisciplinary here. So now I have backgrounds in computer science, electrical engineering, mechanical engineering, and actually working as a team to combine to work on a single patent and actually deliver that was just a success in itself. And going through patent reading, I remember the first time I was reading it, Dr. Nizik was saying, knows patent better than anyone in the country. And I was like, my jaw hit the floor. But it's just such a great experience now, actually knowing how to read claims and what the patent needs to make that and actually design your piece according to that. It's just been really great. And working with such a great team, I'm just very grateful for the experience.
So, so just a note on Brandon too is many times we get in discussions of the business aspect of things too, and being in a contract environment, it's a little bit different. You know, they actually have to understand that there are deadlines, deliverables, requirements. Like we can't just do what we want. You know, very seriously, and always been a great person for me. So you start to see those, you know, those natural abilities come through as well. So again, just with this type of program, is all these different, almost unpredictable things, that these benefits you get out of it and that the students get out of it. So, and then Pranav?
Hi, hi everyone. I'm Pranav Ramanian. I'm a computer science sophomore. I came into the lab like with just very minimal programming language, and I kind of asked Dr. Nizik, "Hey, I would like to do research, or I want to get involved within the ETIC." And he said, "Do you want to do research or hands-on work?" And I right away said hands-on work. So he gave me a few projects to work on. So actually, I worked on Ursula behind me. You could see her initially, and then I started shadowing my seniors, Eva Aga and Benjamin Foucault, who graduated. And eventually, I started moving up the ranks to now working on when I started the first NASA prototype Puma, where I did a operating system for it with the two sensors. And then now I'm working on a project with Lincoln RANCAT, which is a laser EKG. So yeah, this lab has increased my experience, increased my knowledge, and now I found my passion to do like systems engineering, firmware engineering in the real world.
And now, thank you, Pranav. So, and the other thing is that, with each student, it's this little thing that's, kind of hit me as far as things you didn't plan on, but are yet another benefit from this relationship we have with the T2X office is that, Pranav was a natural fit for the Apple internship. So Pranav was also an Apple internship winner, and has also been the contact person for something we started calling the ETIC Math Challenge, which is directly related to the work we do at ETIC. It just engages and attracts, math students that can help us with some of the more complex mathematical algorithms that we sometimes, need extra support with, right? So the ETIC Math Challenge is a program we put on twice a semester, and it attracts 4 or 5, maybe even 10 different math students that are solving complex problems and for prizes and things like that. And Pranav now runs that program as well. So it's just all these different leadership opportunities they get to really, participate in because the need is there, is one more benefit that NASA is providing to us. So, Winston?
Hi, I'm Winston. I'm a mechanical engineering student with a concentration in aerospace. When I was initially brought into ETIC, I was asked to work on ETIC's Dragonfly project, which is a ETIC drone-based program. And with my specialty, or in this case, knowledge about aerospace, I was asked to do that. However, as I kept working, I familiarized myself working with other students, such as our electrical engineers, such as our computer science students. And it also helped me familiarize myself with like circuit building, coding in Python and everything like that. And now I am a project manager here at ETIC, and I can accommodate all my projects for how would this work out in coding, make sure there's enough space to involve a circuit inside. And I just feel like working together with everyone at ETIC has allowed me to learn how to properly function together as a team and how important every single aspect of engineering, including electrical engineering, computer engineering, and mechanical engineering is.
Yeah, and one of the things that again along the way you kind of learn and you adjust and one of the things that happened with Winston was the trigger that when someone gets hired at ETIC, they really need to be required to mentor students. They really be the students that walk in the door. One person can't do it all, and you can't do it in their discipline, right? If they don't walk in and it's not your discipline as a faculty member, it's not a fit. So the students themselves, when they get the job here, they're required now. And Winston was really one of the first ones to really take that on. And now every student is also required to mentor other students as they come in and require help with projects and things like that. So on top of that, they're learning instructional skills, presentation skills. The students today, if I told you when we met them, you guys can vouch for this, but the presentation skills that you have to present on a regular basis now.
Absolutely, yeah.
I mean, these guys, they just blow me away every time they present a project or they present some sort of a paper they did. They just competed in Source. They just won 2 design competitions outside of the NASA contract, 2 different, engineering statewide competitions, first and second place. I couldn't be prouder, and they have to present at all these different things and discuss their work, and it's really always a privilege to be part of that. So thank you all. And last but not least, only because I'm going right to left, is Lincoln Dover.
Hello, good day. My name is Lincoln Dover. I'm a mechanical engineering master's student. Actually, I'll be graduating come this spring, 2 weeks time. So coming into the ETIC lab was a really life-changing experience for me. I came in as a freshman back in 2019, and basically I was just passing to the school. I walked up to Dr. Nizik, and I was like, "What is this place?" And he was like, "Oh, well, this is the ETIC. We do a bunch of robotic stuff here." And I was like, "Oh, that's very interesting." And from that day onwards, I just had this spark to continue coming back to the ETIC lab, see what I could learn, see where I could develop myself as an engineer. Not only to have like the academic and theoretical side, what I've been learning in my classrooms, but as well, I see you could tell kind of the theme of the students that are presented so far. They tell you that they learn not only what they know, but they have to learn as well the programs that are adjacent to themselves. So like learning electrical work and learning computer science work, that's all been like a recurring process for all of us, including myself, having to go through, okay, so how do I make this circuit diagram on paper into like an actual thing that I could, see before me as well? How do I test this equipment using, electrical equipment and stuff like that? So, having to learn those skills, those real world engineering skills, help you to be even perform better in your classroom and to have a better understanding of what it is you're learning. So much so that we could take on projects that are of very high caliber, very high standard, and then we kind of churn them out on a rather professional level, I'd say, as far as we've been able to impress the people that we've spoken to in the T2X program when we met them in Manhattan the other day. And it's really a point of pride for us as well to be able to meet that occasion, to rise to that challenge. And yeah, I hope that we continue to learn and keep getting even better at what we continue to do. So if it's all right with Dr. Nizik, could I introduce the...
We're gonna bring it up in a second.
Okay, all right.
So yeah, so on a very personal note, the best part of what I do is to meet the students and get them going. The worst part is saying goodbye. So Lincoln is graduating, he's finishing his master's and moving on, so going home. He's gonna be the mayor one day of Trinidad, so, but congratulations to everything. Serious, thank you for everything and congratulations as well. Okay, so with that, I'm just gonna transition a little bit. It's hard to talk about all this stuff and see it on slides. We wanted to show you, and we knew we were time constrained, so we just wanted to show you and discuss one project that we're currently working on for period 3 of the contract, and show you the level of design and work and complexities that we work in, just to give you a more kind of practical exposure to what we do. So with that, I will now ask you to show the RenCat version of current version of what we're up to.
Okay, so for everyone watching, This is one of our, I don't know if you've noticed that there are billboards behind us. We were sat, but those are top documents of various of the patterns that we've done so far for NASA in our period 3 project. So this is one of our period 3 projects that we're doing, myself and Pranav as the computer science, and I'd be doing the hardware and the mechanical work on this as well. So this is RENCAT, remote non-invasive cardiac activity tracer. Essentially what it is, it's a laser EKG. So it's meant to point at any region of interest via a laser and obtain the waveform of that surface that it interrogates. Okay, I'll let Pranav go a little more.
Yeah, so right here we have a speaker that is mimicking a heartbeat, and the ultimate goal is there's a Raspberry Pi underneath that is used as a mini computer to analyze the data coming from the sensors, and we would plot that waveform onto this screen over here, and you will see the EKG or the PQRST values that you would normally see on the screen right there.
So one thing that's very important as well, adding to the quality of work that we output. So we just had the idea to have this entire demonstration piece be something that, you know, during the various functions that you might have or whatever the case is, you could pull this case out and you can close it down and then just pull it back up to show us a demonstration piece. Obviously, it connects up to like a keyboard and mouse, so you'd be able to interact with the screen and whatever like that. But the entire like demo piece would just be in here and it'd be encased properly, and then you could pick it up from the handle and carry it around. So we really gaining like fine detail into, you know, how the thing is going to look when we present it, you know, taking into account the people that are going to be using it, because we understand that the people using this device are not going to have the same backgrounds as us. So it's really important to have like, you know, good user interface and stuff like that when it is we develop these sort of technologies.
And one thing that I'll just the idea of the case itself, right, and the ability to build a product. I feel like we're always looking down, so you gotta look at that. But the ability to build a product that T2X gets, just refining it, it builds our skill sets. It makes us think more like a business, and it also under the contract deliverables, it makes T2X happier to get this product that they can take to a show. Now this current one, we have the batteries built into this one, I believe. Is that correct, or is this?
Yeah.
So this kind of concept here, I just want to talk about a 9 to 12 program, high school program. So this case itself, so the tech itself, the product is one thing. The case is standardized. Like we're just going to basically build these cases that have screens and batteries and all that, but they're not really proprietary in nature. They're just the shipping cases we're moving out. It's a perfect project for a high school tech club, math program, robotics program to work on and build, because there's nothing to do with the technology, but there's still an incredibly high-tech job to do. They have to 3D print everything, they have to design. So now this program that we've now reached into high schools to engage with them and recruit them, it's NASA related. It's just nothing to do with the technology. So it's a great solution for us to keep the technology completely separate, but the case just makes the value of the contract that we're delivering to NASA more valuable. On the same note, we're now reaching into 9 to 12th grade programs and really getting them to really think more critically at an earlier level, which just feeds that pipeline of engineers coming into the world. So just one more benefit that the program, the T2X contract, has allowed us to engage with. So thank you again. So Brandon has Puma.
Yeah, sure.
And
So this is the portable unit of metabolic analysis. Team that worked on this was myself and Austin Cecil, who I don't believe is on Zoom today. So I'm the mechanical engineer for the project,
I'm the computer science.
and Austin was the mathematician. So we all worked in collaboration. And just as Dr. Nuri was saying, this is one of 2 ETIC that's in Manhattan, and Austin was in Manhattan as well. So we had weekly Scrum meetings talking about this, getting the actual ideas, bouncing back and forth. Can't even tell you how many iterations we had off of this. Basically, what that means is that how many different versions, V1, V2, V3, etc., of actually making this come to life. So what Puma is, it is the first device of its kind to actually identify the possibility of hypoxia and prevent it from happening. So the way this happens, the functionality behind this, is we have an oxygen sensor here, a carbon dioxide. Oh, it's a little closer actually.
Yeah,
that's great. Come down a little bit. Nice. Okay. Sit back. Yeah. So it's the oxygen sensor here, a carbon dioxide sensor here, and a flow velocity here. The flow velocity sensor works in the sense of measuring the differential in pressure within the internal of the tubes of which you're breathing in compared to the outside, which basically in engineering terms is the static compared to dynamic pressure. So that's basically measuring the quantity of air that you're inhaling and exhaling. So what this does is ensuring that every breath you take, you're breathing quality and efficient air, in the sense of that you have the proper amounts of oxygen in the environment you're breathing in. So all this data, you want to start with the data?
Yeah, sure. So similar to RenCat, we also have Raspberry Pi here. Raspberry Pi is essentially what we use in-house for any projects in the lab. So we have a Raspberry Pi here. So the data that's coming from here is being sent through a script that Austin made in the Manhattan side for it to be plotted into a volumetric flow rate of O2 and CO2. And we're outputting those results as well as the heart rate and the raw O2 and CO2 values that are being picked up by the sensor.
So everything that you see in gray, the actual housing, the tube splitters, the housing of the flow velocity, and this piece that's actually housing the Raspberry Pi was all designed in-house by myself on CAD and 3D printed, and all of the actual functioning programming was designed by Pranav himself. And actually Pranav and also working in collaboration for making that coding, which is a very complicated method, to say the least. It was very difficult, but it's worked great. And we secured more contracts just based off this one prototype. So it was a really cool piece to be part of, and it worked great.
So Puma was a finished product and delivered. And RenCat is under development in this year's contract. And then currently we have one that Joanna's going to talk to you about called Zone, and how that's going to kind of work as well.
Yes, so another plan that we have is Zone. To work with Lincoln here, you can explain the requirement.
Yeah, so this is just conceptually the casings for the zone training module. Basically what it is that zeroing out negative effects. So it's a training module to help people to
enhance athletic performance.
yeah, exactly. Just basically increasing the difficulty of any performance of any task that you do to allow the person to get better over time. And so with that, we have a combination of sensors and onboard microcontrollers and stuff like that we all kind of have encased in this type of casing that's 3D printed, designed by myself as a mechanical engineer, as well as so for all of the electrical work. So when we, like Joanna was talking earlier about like having to solder the PCBs together and the wafers and stuff, so we'd have done that together as well, and she would have done the programming for all of the sensors that we do to take actually the biofeedback into, and then to interpret those readings as well to output for the user. So she could talk about.
So we went through a lot of versions of EMG sensors that we had to test for the qualification of Zone. We found one EMG sensor finally that would work with our patent, so we had to implement all the requirements or claims of the patent. For example, physiological the difficulties, which we're using physiological devices for the Zone, as well as the sensors, zones, switches, displays. As you can see, this is version 1. We have a prototype right now that is working, but this is just to show the version 1 device that this will go on your arm. So on your arm, on your body. We are also going through different types of straps or velcros to put, because this device will not only go on your arm, it will go on different types of muscles, and you'll have to put those muscles to test and to check for difficulty.
So that's just to show conceptually how the training module would work and how we kind of designed this to aim towards being a product that you could actually show off to other people, like we say, for events and such like that, so that they'd be interested in continuing to develop them further on a commercial level.
So one of the things, before I kind of finish up, go back to the slides for a second, but one of the things that we experience here is the informal and impromptu discussions, sometimes almost heated, that, what's going to work, what's the process to do it, different students have different approaches and they want to finish on time, and that's really part of the industrial process anyway, and they get to learn that and experience that here. But they also get to think entrepreneurially. In other words, what NASA's T2X office lists in their TOPS documents is great, and it gets us thinking, but as they're building it, they get into these discussions about like, it could be used for this, or, hey, they didn't list this, but it could be used for this. And it's all these different industries and discoveries that we try to also give back to the T2X office as well, of things that we just see in the process, that are, different things that we didn't really realize were possible, industrial solutions. Okay, so that's another thing they go through. I'm just going to go back to sharing for a second here, and I'm going to finish up one portion of this. Okay, and just to give you an idea of kind of right, what's happened. Right, our abilities and prototyping abilities has improved greatly. Students' learning is accelerated. We know the number of students keeps increasing that we're able to provide with this program. We have a New York State and really a national resource now for prototyping that we didn't have before. So that makes it wonderful to have that. And then we have regional resource for talent. So we have companies that kind of cherry pick, from the ETIC, which is great for feeding people into industry. And then we get great visibility for the College of Engineering and Computing Sciences, which hopefully in some ways keeps us rising on some of the rankings and all that we do this type of work. And again, we've become a lighthouse for other institutions that come in to see how we're doing things and what's successful, what's not, and we take great pride in that and how to help that process along. So what's next for us is the scalability. How do we do more, right? How do we involve more students with more complex projects and extend our reach in region and do things for NASA that we maybe haven't done in the past? How do we, start to manage our assets better? Every time we build something right now, we store it as part of our asset library, which is part of our go-to library that we can build quicker now because we built something once. We don't have to build it the same way every time. We take modules and we can put them together and build, better and faster as we go through. We're constantly making enhancements to the ETIC. We've got our first carbon fiber printer. We've got a bunch of other electronic components that we didn't have before. So, and we're starting to do students who get structured project manager now, which was required. We just didn't have to do it before, and we could be a little more ad hoc. And now it's impossible to manage our projects to meet these deadlines for different phases of the project without actually having structured project management in place. So the students are now learning that process and also engaging in that process as we go. And most recently, we've had the 9 to 12 high school engagement, which we didn't have before either, and that's a wonderful pipeline and feeder to that. So with that, I'm gonna end my portion. I'm gonna end with Dr. Vashti. If you have any final closing arguments, or
I hope we shared some of the excitement with you. I mean, really, the best part of it is to see the final product, right? So they come in, fairly inexperienced, some inexperienced altogether into ETIC, and through the programs like this contract with NASA. As you see, they are mature, confident, experienced engineers, ready for the job market. So thank you, our T2X partners, and thank you everybody for spending the hour with us.
Thank you.
Thank you. Thank you all so much. We kind of ran out of time for questions today, but we'll certainly take any that have been put in the chat box and relay them over. But I just wanted to just personally extend my thanks to all of you, especially, the students back there, Joanna, Brandon, LinkedIn, Pranav, Winston, Mikhail, and everybody, who isn't online today too, who's also contributing to that project. We greatly appreciate the work, and it's really great to hear about, the opportunities that it's provided for you all as well, to move forward, with your lives and advance your careers and your educational experiences. So thanks so much for the great partnership. Thank you, Mike, and your team for all the great work and for being with us today. Just that you'll be getting an email, I believe, with a link to the webinar as well, if you've registered. So that will be coming to everybody. All right. Thanks so much. That concludes for today. Everyone have a great day.
Thank you.
Thank you.